Um, this is the grand field of them all. This is both the addition field and the multiplication field of the what I've been calling the field of nines. But actually, it's two dual fields that sort of play off each other. There's a 369 field, and there's a 471 field. The 369 field are the larger numbers, like the nines and the red numbers. And they're all individual patterns too. I'll get to that. But the larger field is addition, and you get the addition through the neighborhood method, is what I call it. The surrounding neighbors of the, like for instance, 9, 8, 7, and 9. You add those together with larger numbers, and then numerologically reduce, is what I call it, to a single digit. You get 9 in the center. And you do that with the smaller numbers too, like 9, 7, 9, 9. You add in there in the center, you multiply in the center of those to get next generation. But what I've already figured out is that the smaller numbers are terminating. They don't generate. They terminate and they're embedded in the larger numbers, which are the addition numbers. They generate because they're addition. The smaller numbers are multiplication in the neighborhood method, and they terminate. They all go to 9. And the smaller, I'll start running through this in a second. The larger ones, you got to look for the 9s, the 6 3s and 9s, and then the smaller numbers, you look for the 7, 4s, and the 1s. So there's the 7s, and the rest of the background are 9s. There's the 7s, and here's the second generation for the addition, the larger numbers with the neighborhood method. And this is the first generation in the embedded terminating smaller numbers of the 471. And so the last one was 7s. This one is 1. You see the 1s, like the 9s were betrayed in the last one, or betrayed in the last one. The 1s are now taking this up a squared type of place. And you'll notice the 9 shifting too. The 9 shift up. And this is part of a larger, whole field, and I'll get to that in a second. But now this is the 4 field. So that was 7, 1, 4 in the green. The 4s with the backgrounds of 9s. This is the 7 field again. 7s, the smaller numbers, the multiplication in the neighborhoods. 7s with the background of 9s. Then 1 again, the smaller numbers. And you can see the 9s, the larger 9 numbers shifting. And then here's the 4s again, the smaller numbers and their patterns. And the 9s are shifting upwards or somewhere. And then here's the 7s again, and the smaller multiplication field. 7, 7, 1, 4, 4, 4, 7, 4, 1, or whatever. And then the larger 9s are shifting. Then here's the next field. 9s are shifting. This is back to 1s again. Up there was 7. Before that was 4. Now it's 1 again. And then for the final 9th field of the generating additions is this, and it's back to 4 again. the fours and the smaller numbers. The smaller field is the embedded field that doesn't generate. It terminates on each of the generating field generations of the larger numbers, the addition field. So addition is 369. Multiplication is 471. Because you've seen the 7, the 1s, the 4s, the 7s. It goes like that. Addition field is the larger numbers. I chose to make them larger, but you can make the multiplication larger and have the addition number smaller. It'd still do the same basic field. And these are all the fields that are contained in a generalized field of nines. But the real name for this is two dual fields of 369 and 471. The 369 are the larger numbers in this instance, and they're 369. And the reason 6 and 9 are included, 369, is because they never make the central patch, the zipper effect, I think is what I call it. They never make the central patch. It's all these other types of sequences. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. They crisscross each other too. There's 2, 4, 6, 8, even. 1, 3, 5, 7, 9, odd. There's 3, 6, 9, 3, 6, 9, 3, 6, 9. And these are the leaping numbers. 4, 3, 2, 1, 8, 7, 6, 5. Then these are their inverses. 5, 6, 7, 8, 4, 3, 2, 1. These are the inverses of 3, 6, 9. Is 6, 3, 9. This is the inverse of the odds and evens, or evens and odds is odds and evens. 7, 5, 3, 1. And it's even. 8, 6, 4, 2. And then these are the normal or the regular sequences. 8, 7, 6, 5, 4, 3, 2, 1. Those are the four basic strands of sequences that make up all of these fields, all of the larger numbers. The smaller ones all consist of 7, 4, 1, and the background of smaller nines. So I'll run through this again. And these are the generating fields of the larger numbers. Embedded are the smaller fields of the green numbers, of the multiplication numbers. And what I hope to do when I get the money is make a complete field out of plexiglass model, a three-dimensional model. And this only shows the first field of the generations of the larger. It shows a expanded out infinitely. I can make it an infinitely expanded field, but I can get plexiglass and make a large patch of repeating patterns that are supposed to expand down to infinity. And that's just the first field of the larger numbers of the addition. And this is what I'm talking about. I'm hoping I could make some sort of get some plexiglass and make a larger field that, like I just showed you on the whiteboard. And these are just patches, but I want to make them repeat like at least probably about four squares worth to show that they go off into infinity. And these are only the larger field numbers, but if you added in the 417s or 471s, that would be more numbers. And I'd hope to make it larger and spaced apart more. But I think this is all I have to say about all of these. And I hope you follow it along, because I think these are really interesting. Well, thanks a lot.